part C.3, hint for test 1 question number 14. Yeah. So this question, quite challenging. Yeah, pretty challenging. Phi, the golden ratio. Here the question, this expression, phi to the 2n plus 1 over phi to the 2n is a positive integer for all positive integer n. Yeah. True or false? Because here nobody can verify it using direct calculation, right? No, you cannot. Yeah. Here, in order to see if it is correct or not, you need to use the right way to see it. Here, this question is mainly used as an exercise question for mathematical induction. Mathematical induction. Yeah. Here, although I didn't mention mathematical induction, right? Yeah. I do not want to say it directly or point to that direction directly in the question. Yeah. Yeah. But here, as a hint, I'll let you know when you really want to see if statement is true or false, you can try to use mathematical induction to verify if it is true or not. All right? Yeah. So here, let me give you part of the information. Now, you need to complete the whole calculation or verification part. All right. First, let us consider when n equals 1. Simplest case. When n equals 1, can you see phi squared plus 1 over phi squared is an integer or not? All right? Yeah. If not, then you have the answer already. Yeah. All right. But we need to do some calculation first. Yeah. But in order to do that, let us use the 2 properties of the golden ratio. Yeah. Phi squared equals phi plus 1, right? That is the first property. The second property, 1 equals phi squared minus phi. Right? Yeah. So these 2 properties. Yeah. Now, let us try to simplify this expression. Yeah. The most complicated part is the fraction part. So we want to simplify the fraction part. Yeah. 1 over phi squared. Can we replace 1 by this expression? Phi squared minus phi over phi squared. Right? Yeah. That's 1. The first time we apply one of the 2 properties. Yeah. After simplification, we have phi squared plus 1 minus 1 over phi. How about that? All right. Then there is another fraction that is not quite friendly for our simplification. So we want to work on this fraction another time. When we work on it, you see this 1 another time, right? 1 in the numerator. Can we do the similar simplification? Replace 1 by phi squared minus phi, right? Yes. Over phi. How about that? Can we do the simplification? Yes. Yeah. Let's do it. Phi squared plus 1 minus phi plus 1, right? How about that? Okay, let us simplify another time. Phi squared minus phi plus 2. How about that? What is this phi squared minus phi? Look at the second property. That is 1, right? So 1 plus 2 equals 3. Is that positive integer? Yep. So the base case looks fine. We verify it is a positive integer. All right. Yeah. Okay. Then the next step, mathematical induction, right? So we need to make induction assumption. Induction assumption, yeah, the second step. Yeah. The induction assumption is phi to the 2k plus 1 over phi to the 2k is an positive integer. Just as assumption. Yeah. Next, we need to show that phi to the 2k plus 1 plus 1 over phi to 2k plus 1 is also an positive integer. Right? Yeah. So that's the standard way using mathematical induction. Yeah. But to show this expression also positive integer may not be very easy. Right? May not be very easy. But here, let me give you a critical formula. Here, I just give you that critical formula. If you see this formula, I hope you can solve the problem with some effort. All right, so the critical formula is like this. Yeah. Look at the multiplication of this. Can you do the multiplication like this? Okay. If you do the multiplication, you will have phi 2k plus 2 phi 2k plus 2 phi 2k minus 2 plus phi 2k minus 2, right? Can you see that? Can you see that? Right? Yeah, it's a positive integer, but your mathematical induction, so let me erase the base part. I think you can easily recover this part, all right? Or you just take your note. Yeah, I need some space here, all right? I need some space here, all right? The mathematical induction, this is a positive integer. And can we also, when we make assumption, can we also make another? Because the mathematical induction allows us, when the exponent number, smaller even number, it is also a positive integer. Also, yeah, here, how about we just assume it's an integer, right? Yeah, here we do not need to positive, because this expression is positive, right? naturally positive. So positive, it's natural. We only need to show it is an integer. That's enough. Okay? Yeah. So we can skip the positive part. All right? Is also an integer. How about that? Also an integer. All right? Yeah. Because the mathematical induction, there is a version, strong version. All right? Weaker version, we only make assumption on one. Strong version, we can make more than one. All right? So this correct. It's an integer. And when the exponent number less than that, the previous even number. So this is a previous even number. Also true. Yeah. Previous even number. Yeah. And this expression also an integer. When we make induction assumption, we can make that. That is the stronger version of mathematical induction. There are two versions. Yeah. Two versions. Usually people call it version 1, version 2. Here we use the version 2. Mathematical induction version 2. All right? So it's legal. It's the correct way, legal. Yeah. All right. So this expression, integer, that expression, integer. So now, integer times integer. All right. This is also integer. Is this an integer? Can you see that? Right? Yeah. You look at the identities. This is identity, right? Identity. Look at this identity. Always true. Always correct. All right. Left-hand side, is that an integer? Right-hand side, two terms. The first term, we don't know if it's an integer or not. But we know the second term, second parenthesis is an integer, right? Can you get a conclusion if the first parenthesis of the right-hand side an integer or not? All right? So that's already plenty of information. Now, I hope after you get all the pieces of information, you can connect the dots. Connect the dots and get your answer. How about that? All right, so that is, a lot of information about question number 14.